Hey, welcome to the last in the series of presentations on number. This is part 7, and let's have a look around the screen. Lots of numbers there, and of course if you look at the red ones, it looks like they're somehow connected to this symbol here, all in red. Okay, something to do with that. And this is actually called the square root of x, where x could be any number, the square root. And later on you'll see this sign, which is called the radical sign. A radical sign, meaning here the square root. It can be used for other things too later on. So we're going to look at the square root of numbers. What might that mean? Well, I think there's a clue in the fact that the numbers were all squares here. 2 squared, 3 squared, 4 squared. And if you take the square root of it, let's have a look at what it says, you're going to get the number back again. So the square root of x represents the opposite operation to squaring. It undoes the squaring, if you like. Okay, so the square root of 2 squared is just 2. Well, that is the square root of 4, and that's 2 also, another way of writing it. So we're saying with this sign, what number squared gives 4? What number squared gives 4? And so the easiest way of seeing that is to see that 2 squared is 4. So undoing that, the number squared to give 2 is 2 squared, is 2. So let's do it again. The square root of 3 squared is just 3, because this sign, if you like, undoes or reverses the operation of squaring. So square root of 3 squared, square root of 9 is 3, so you can put it like this if you like. Or square root of 16 is the same as square root of 4 squared. This square root undoes the squaring, so the answer is 4. Do you get the idea there of the opposite operation? So that's what the radical sign here, what the square root sign is used for here. All right, so fairly simple idea. What we want to do now is to practice that idea and also to use the calculator. So come on down and let's see what the calculator can do for us, because you would realise not every number is a perfect square, and therefore you can't work out exactly as a whole number the square root. We'll have a look at that in a minute. So if you go to the Casio 9860 Plus, it's a great calculator. Highlight the Run Map mode there, and then if you push execute, you go into the run window, and what I've done is chosen, come in here, watch this now, there's the square root in there. So what do? You have to push shift and then the x squared button. So I'll get rid of this, so you push shift and the x squared button. It's the reverse or inverse operation to squaring. So that's the way the calculator is displaying it, as coming backwards from squaring. So that gives you this sign, and then you can enter 25. And what's the square root of 25? Well, that's a perfect square, isn't it? A perfect square is a natural number squared. Perfect square. Okay, so the square root is going to be an integer, a positive whole number, because this sign means that positive number squared, which gives you 25. So the square root sign means the positive answer, okay, the positive answer to what number squared gives our number under here. So you might try something like the square root of 2. Now you would know, I would guess, that there's no whole number square exactly gives the square root of 2. So if you put that in, you could use an approximation sign and you'll get 1.414. It'll keep going. So for numbers that aren't a perfect square, okay, you'll get a decimal approximation from the calculator to what the approximate number is that when squared gives 2. There's no exact number squared gives 2 that you can write as a decimal. We'll come across that later on. It's called an irrational number. All right, so let's go down and do some. And if you do, here we are, 1F from Hayes and Harris Publications. So it could be good to have that book close by now. Now, Here's some warm-up exercises to find the 6th, 9th and 12th square numbers. So 1 squared, first square number, 2 squared, 3 squared. So that's the idea. Perfect square numbers are natural numbers squared. Okay. Use the calculator to find the largest 3-digit square number. A bit of trial and error there. The largest 3-digit square number. Okay. How would you do that? Have a go. Okay. And from using a calculator and thinking about it, the square of an even number is what? The square of an odd number is what? What can you say about those? So you might try squaring some even numbers and some odd numbers and seeing if you can see the pattern there. Is there a pattern? Okay. Without using a calculator, here's some perfect square numbers and then some with the calculator. And here, between two consecutive integers. Consecutive integers are ones that follow each other. So 2, 3 and 4 are all consecutive. 4, 6, 9 are not. There's one missing here, there's 2 missing here. So consecutive means they are in sequence. No gaps, no integers missing in between. Okay, so see if you can estimate these numbers and then check it with a calculator to see what their approximate values come to. Okay, so there's question 7. Have a go at all of these, toggle forward and back because I'm going to show you the answers now. So you should check your answers as you go to make sure you're not making a silly mistake over and over. Okay, let's go down there and have a look at the answers. All right, there we are. Particularly want to look at question 7 because that's a little pattern one, a little extension one. Question 7, and see what you think. Okay, I'm going to leave you now, and I want you to go back and revise all the presentations in number to check your knowledge, ready for any tests you might have. But I'll catch you in another presentation. Cheers for now.